going to tell you today about a project that we're doing at our school. It's called Vita. Viridi. Does anyone know? We want it to be Latin and fancy. Does anyone know what it means? Can you guess? What Vita? That's easy. That means life. Yeah. Viridi, less common. It means green. So green life. I'll explain what that means in a second. First, let me give a bit of full disclosure. Okay. I'm I guess I'd describe myself as a former STEM cynic. Here's what I mean. You know when you've got your class and starting up for the year and you've got your introduction to the class, right? Your class rules, all that kind of thing, right? One of the things I sometimes have been guilty of telling my students is, look, don't ask me the question. You know what question it is. Don't ask me, right? Don't ask me when you're going to need it in the future. I don't care about that question because we don't study maths because it's useful. We study it because it's interesting and it's beautiful. Now, I still kinda stand by that statement, but well, it's kind of wrong. Yes, I believe maths is beautiful and it's interesting, but that doesn't cut it for 95% or whatever percentage of the population it is that really wants to be able to use something, right? So I identified a lot with this comic, right? If you don't read XKCD, you should. This idea of maths really real maths is pure maths. That's kind of where I came from. But I've come to believe, even though I still get a bit of a chuckle out of this comic, I think this comic is mistaken. I think it's mistaken. It makes a good point, but it's mistaken. Because there's kind of this picture, as you go from left to right, that as you get more mathematical, you sort of go away from reality, away from real things, into kind of imagined things. And I don't think that's true. I think ultimate reality is mathematical, and science helps you see that. I mean, examples, right? You know when they talk in videos or on the news about so-and-so, scientists predict there's going to be such and such, right? Einstein and his curvature of space-time, or the Higgs boson, or whatever it is, right? How did they predict that? What does prediction mean in a scientific context? And the answer is, it's maths, and there's a solution. We don't know what it represents, but it should represent something, right? Or we're looking at knot theory. That's one of the most esoteric, random, useless kinds of maths that there is. Like, how do my headphones turn into this awful mess? But it became critical in understanding the mathematics of DNA, which Naomi was just looking at. One last one, which is my favorite, is string theory. If you know what string theory is, it's basically a theory that everything, when you boil it down, is little vibrating strings. Vibrating strings. Maths teachers know what vibrating strings are. I think string theory should be renamed. I think it should be called everything in the freaking universe is made of sine waves, right? Trigonometry, when is it useful? You're made of trigonometry, right? So we shouldn't have to settle, and our students shouldn't have to settle for things just being completely pure, right? So this is the way that we're doing it. I'm going to answer 3 questions for you. What? I'll give you a basic overview. So what we've learned so far. We're still in the middle of the project, I should mention. And now what? Where are we going in the future? Where might you go in the future? So here's some background. Cherry Technology High School, it's a technology high school. In some senses, it was built specifically to do STEM. And in fact, this is our combined staff room. Hold on, hands up. How many people are in a school with a combined staff room? Anyone? Yeah, okay, thanks, hands down. I went to a school with staff rooms everywhere, and I worked in schools with staff rooms everywhere, and then I walked into this. This houses about 75 staff. It used to house the entire teaching body, but the school has since grown, which I'll talk about in a second. So now it's only about it's maybe 2/3 of us roughly, okay? But the faculties that are left inside the combined staff room are science, technology and applied sciences, and maths, right? We're all there. In fact, we even have we have Kappa in there as well, creative and performing arts. So if you wanted to go the whole STEAM direction rather than STEM, you could do that too. So this is our school. The theme we decided for our project is overpopulation. Overpopulation, and particularly urbanization. I said that the school has grown. The campus was designed for about 800 students. Currently, we're pushing over 2,000. And it's been like that for quite some time. And you might think, far out, I can't even picture that number of students. Neither can we. Actually, our school hall is huge, but it can never fit the entire student body at any one given time. In fact, the only time we see all of them is when we do a fire drill. So that's it, right? Even we don't really picture the whole school. It's very obvious that overpopulation and urbanization have been affecting our school. We wanted to channel channel the students' efforts in a particular direction. So for the actual project that we wanted our students to do, we focused on a single environment within the school. This is a bit of a snapshot of the top playground in our school. And you can just kind of make out, if you look here, can you see how this part of the picture, that's just, it's the ground, but it's a bit shiny, can you see that? So this is after rain, and if you can really, really squint, what you've got is we did the maths, I estimated about 5 kilos of dirt that has just funneled its way down from the topsoil of the top playground down to, there's a drain in the middle of that. So our top playground, it used to be this grassy, idyllic, green, alive place, and it's not anymore. So that's what we decided to focus on. We've run it as a semester course in stage 5, years 9 and 10. We don't do 2-year or even 1-year electives, we do 6 months at a time. So that's why we're halfway through this project. And we've got our students, about 20 of them, in groups of 3 or 4, to try and tackle this problem. So let's have a look at some of the mathematics that we actually did, since that's what we're focusing on. Number 1, here's some satellite photography that shows you the top playground of our school. Those 4 square-looking things on the left-hand side are the 800 students worth of area, and over here, just for kicks, this is our 39 or 40 or 41 demountables over there. Okay. Now, what I've highlighted in red is the top playground, and it used to be entirely grassed. It's not anymore. But we wanted to work out things like, well, okay, one of the first solutions that students jumped to was, let's just cover the thing in AstroTurf. Okay, we can do that. It's a bad idea, but let's just see, right? Well, is that going to be feasible, like financially? How much is that going to cost? And they just threw out numbers randomly. We need some numbers on this, right? So we had to look at dividing it up into composite figures. You can do Simpson's rule on this thing to quite a degree of accuracy. Speaking of accuracy, we looked at the limits of accuracy. You can get the spatial information exchange that the government runs. It does an estimation of this area of the satellite photography. How does it do that? Limits of accuracy, all those kinds of things. We decided to do a fundraiser. We went to the Athletics Carnival, which at our school you can imagine is quite a large affair. And we thought, okay, if we want to do something in the top playground, it's going to cost money. Let's raise some funds. Let's do the biggest sausage sizzle you've ever seen. And let's see how much we can earn in terms of profit. Well, this is what happened. We had the carnival a few weeks ago, and we were comparing, okay, what's the expenditure going to be like? What's your profit margin going to be like? How much are you going to sell? What's your predictions? What's the weather going to be like? And how does that affect everything? So budgeting expenditure and doing the spreadsheets on it is a big deal. In terms of, okay, we're going to sell all of this stuff, how much should we price it, right? Optimal pricing range is an area of economics, but I don't care. I see numbers and lines. This is my department, right? So I thought, let's talk about how do people decide, how do marketing teams decide what's the price range that you should fit so that it's low enough so enough people buy it, right? But high enough so that you make a sufficient margin off it, right? All these really interesting questions that we tackle with our students. One last one, even though there are more, but just to keep it brief. This is a traffic problem, really. Part of the problem in the top playground is the students, I'll just come back, students need to move around all of these classrooms up here, but the paths to let them move along there are not sufficient, not nearly, right? It's like the M2 on a bad day, right? So instead they walk over everything. It's not like in the main quad where everything's all walled off, they have to walk through the grass, right? So how did we think about how to analyze that problem, where the choke points are, how to design a solution? There was a lot of statistical analysis that went into them, observing the playground, looking at where the kids moved and when. The numbers are crazy, it's great. So, what have we been learning, both students and the teachers, as we went through this? Number 1, because we're going cross-faculty, there are 4 teachers on the team, there's myself, 2 science teachers and a design teacher. It is a little bit tricky to coordinate. You can't go into this all idealistic. It's going to be wonderful. We're just going to have this wonderful symphony of everyone working perfectly together. You've got to work really hard and spend lots of time at looking at each other's KLAs, looking at the curriculum, and planning it out really carefully. Like, this looks really nice because I've given it to you in 60 seconds, right? But it took weeks and weeks and weeks of combing through the science syllabus and the design syllabus and the math syllabus all together to try and work out how it's going to fit. So coordination. Secondly, the expectations of everyone get suspended when you do something like this, which is both a plus and negative. Students walk into the classroom and there's more than one teacher in the room, or there's a different teacher from a different subject, and what is this? How does this class run? is actually a really healthy way to get yourself away really deliberately from turn to exercise 309 and then do blah, blah, blah. This will force you out of your shell, okay, which is really good. Team teaching was so fantastic, actually just standing in a classroom and watching a science teacher or a design teacher just do their thing. They approach every problem differently to the way we do, right? It was a really great way, particularly if you've been teaching for a while, to broaden your way of thinking, how do students learn in this environment? And lastly, even though it did cost us, or it's still costing us, a lot of time in addition to the way we normally teach it, extra effort's been really, really valuable. For the students, just authenticity and community involvement and engagement. We've got a lot of companies in soil scientists, the local bank, all these kinds of things. It lends a really sort of healthy flavor to the classroom to say, look, this really matters, right? They stop asking the question of when do I need to know this, because they want to know, because otherwise they don't know how much to price all of their products at, or whatever it is, right? Even for us as teachers, I know I've learned a tremendous amount about how much mathematics is woven into every subject, and how much, well, we're actually missing this huge opportunity when students say, hey, sir, miss, what about this thing? You say, oh, don't worry about that. That's someone else's job. It's our job, right? We as teachers, we teach the whole student. Why would we miss this opportunity to connect what we know in maths and what we teach in maths to the other subjects? Okay, now what? A few lessons. Great, perfect. Firstly, we're going to go present these when students are finished to the school exec, the school senior exec, and a bunch of community stakeholders. That's what they're going to do. In semester 2, because the project will finish at the end of term 2, we've got lots of doors that are open. There's so many opportunities. Just Naomi's work at the Opera House is really inspirational. Formula 1, submersibles in schools. There's lots of industry trying to reach in and provide opportunities. We just have to use them. And so I want you to think about your school. I've got a couple of tips for you. Number 1, is project-based learning something that your school is heading towards? If it's not, probably will be soon. I know even just recently we saw in our local school area a bunch of head teachers are getting together, and a number of schools, they're taking time away from their core subjects, English, maths, science, and they're handing that over to, all right, teachers, submit a tender, run some kind of project-based learning thing, right? It's coming, it's happening. Why not lead the charge and actually take advantage of it? Go and have a conversation with teachers in other faculties, right? It's really easy for me because I'm in the combined staff and I just get up and I walk 10 meters that way and have a science teacher, right? Maybe it won't be that easy for you, but you'll gain a lot out of it in terms of how much maths is actually involved in it. They kind of skirt over it a lot, but you can really major on it. Go sit in on some of their lessons and help them out, be the guest expert on the mathematical side. Lastly, just a practical tip. If your school or you decide to do something like this, run a project, something completely new, my big tip is to think of the people who are going to be running that, the teachers, and then the project second. There are way too many fantastic concepts that fail for really poor implementation, so you want to have people who are on board, who are excited, energetic, and willing to work across KLA lines. Thanks for listening. You can see videos of us teaching through all that curricular areas and economics and all that kind of thing. They're all there. Have a look. Hope it's useful. Cheers.